Binomial theorem expansion. You guys are going to learn how to actually expand a binomial with when the degree is a rational number. Okay, a rational number are numbers that are fractions. So now our degrees are either going to be fractions or they're going to be negative numbers. And so we're going to be looking at the expansion of these binomials in these particular cases. Okay, this is not a hard concept. It just becomes challenging when with the formula, because it's a formula that's not given to you in your reference booklet. It's one that you are going to need to know. But it takes into account formulas that are in your reference booklet, so you really could kind of use the formulas you do have to create the formula for these types of binomials. So, all right. Now it looks like a lot. It really isn't. But the binomial expansion for 1 minus x to the negative n power, where n is the element of positive integers, and x is between negative 1 and 1, is given by the infinite series. In other words, this binomial expansion is not going to end when you're dealing with a negative exponent. Look at me and listen to me first. I'll give you some time to write down the formula, okay? With these types of binomial expansions, they are not going to end, okay? They are part of an infinite series. So you're not going to be asked to expand a binomial like this completely because it's impossible. It's going to continue to go on forever. It's going to ask you something like expand to the x to the third term, okay, or the x to the fourth term. So it gives you a set number that you're going to expand to, okay? And if you notice when I give you the opportunity to write down the formula and you analyze it, you're going to see that, oh snap, there's a pattern there of something that I recognize, okay? So let me just read off the formula real quick, and I want you guys to follow me, make sure you understand, okay? Then I'll give you a chance to write it down. So the binomial expansion, when it's 1 minus x to the negative n power, it equals 1 plus n times x plus n times n plus 1 over 2 factorial x squared plus n times n plus 1 times n plus 2 all over 3 factorial x to the third power. Are you noticing any trends here? You got in the denominator, you have factorials. Technically, this is 0 factorial. What's 0 factorial equal to? 1. This is 1 factorial, which is just, and then it goes to 2 factorial and 3 factorial, and it will continue on and on forever. Okay? And in the numerator, you have 0, well, not 0, but you have n times n plus 1, n times n plus 1 times n plus 2, and then it continues. This time, instead of subtracting 1, you're going to add 1. Okay? And then the x's are coming from your second term. Okay? So the reason why it's x squared, x to the third is because we're basically taking the second term in the binomial and increasing the exponent. Whereas the first term's exponents are continuing to decrease, which, 1 to any power is always going to be 1. Okay? So, the main thing you need to take away from the first formula is that this is going to continue forever. Okay? And for your numerator, you're just going to continue to add 1. For your denominator, you're going to continue to increase your factorial. And then, of course, for your second term, you're going to continue to increase your exponent's degree. Okay? Until the term you're looking for, the term you want to get to. Okay? And like I said before, the reason why this goes on and on forever is because when n was a positive integer, it stopped at that n plus 1 term. There was you made it all the way from 0 to your exponent, or starting from your exponent all the way down to 0. It had an ending point. These aren't going to have an ending point. When that's not a, that's alpha. In the binomial expansion for 1 plus x to the alpha power, where alpha represents p over q, in other words, a rational number, is given by this infinite series, okay? So when your exponent is a fraction, it's very similar of a formula to the last one. The only difference is, besides the fact that they're alphas now instead of n's, what differences do you notice between the second one and the first one? It's a minus 1 instead of a plus 1 in your numerator, okay? But it's literally the same setup. The reason why they use alphas instead of n's is because now this is a fraction, okay? It's now a fraction. So then it becomes 1 plus alpha times x, so whatever your exponent is, times x, again, your second term, plus alpha times alpha minus 1, all over 2 factorial, x squared, and then it continues on and on afterwards. Continue to subtract 1 from your numerator, increase your factorials in your denominator, and of course increase your exponents as well for your second term. Let's do some examples. Okay. So let's expand the following up to the term x to the third. So like I said, when it comes to these negative exponents and these rational exponents, they're going to tell you how far to expand them. Okay, in this case, for both of these, we're going to go to the x to the third term. And for the first one, we have the square root of 1 plus 2x, and this is for all the x values that are less than 1/2. Okay, these are just, right now we're just practicing on the expanding part. Later we'll get to ones where we try to evaluate different terms, and so that's what the kind of the restriction is there for. This only works for the values that are in between -1/2 and +1/2. Okay, or that are going to be defined for those. So first thing we want to do is we want to make sure that we have it in either one of those forms. How can I rewrite the square root? Say again. You write it as a 1/2 exponent. Okay, so don't forget that whenever you have a particular root, that can always be written as a rational exponent. Okay, and by seeing this, we can see that, okay, we're going to need to use, is it going to be the top formula or the bottom formula? Out of the 2 formulas that you wrote down, the one that was at the top or the one that was at the bottom? The one at the bottom, okay? Because this is a rational exponent, okay? And based off of the formula, it said that the first term of the expansion is going to be, what's the first term of that expansion? It was 1, okay? Let's go back some, okay? So we're looking at this formula down here. As we can see, the first term was 1. The second term is alpha times x. What's alpha in this problem? The alpha is 1/2. That is our exponent, okay? So alpha is our exponent. So then it's going to be plus alpha times x. Well, x in this case is not just a regular x. It's a what? It's a 2x. So we're going to plug in 2x for every x that we see because it represents our second term. Okay? So for those who might be having a little difficulty seeing, this is set up in the same way as 1 plus x to the alpha power. 1 is 1, x is 2x, so everywhere we see an x in the expansion, we're going to plug in a 2x, and everywhere we see an alpha, we're going to plug in a 1/2. Have I lost anybody? Now, I don't have to go far, I only have to go to which term? Which one? No, not the third term. The term that has x to the third in it. So technically that's our fourth term. Because right now we have x. We just got to keep going. Then it says plus what? What's the formula say? Alpha times alpha minus 1 all over 2 factorial times x to the second power, but I'm going to plug in a 2x, and then I'm going to square that. I should have known that I wasn't going to be able to fit myself in this little space. So I'm going to continue to go through that dotted line to make sure I get the rest of it. Are we okay? We're just plugging into the formula. Then it says alpha times alpha minus 1, then alpha minus 2 all over 3 factorial x to the third, correct? But I'm going to put a 2x instead of an x because that is my second term. And so far we've plugged in everything successfully into the formula. Are there any questions? Now at this point it's just a matter of simplifying, okay? Our first term is going to stay a 1. What is half of 2x? Just x. Now here, we might need to do a few algebra steps. First off, what's 1/2 minus 1? So right now I have 1/2 times a negative 1/2 all over. What's 2 factorial? 2. And then what's 2x, that quantity squared? 4x squared. I can continue to simplify this because doesn't 2 go into 4? How many times? 2 times. So now this becomes a 1/2 times a negative 1/2, which is what? Negative 1/4 times a 2x squared. Does everybody see what I did? I simplified this denominator with 4 to get 2. I multiplied 1/2 and negative 1/2 to get negative 1/4, and then that 2 just turned into a 2x. Can I continue to simplify this term? What does it turn into? So negative 1/2 x squared. I don't know why I put this equal sign on good. Well, this is a part of an expansion. So I'm going to continue to bring down the x, continue to bring down the 1. Now let's do this last term. I have 1/2 times a negative 1/2 times a negative what? What's 1/2 minus 2? Negative 3/2. What's 3 factorial? 6. And then what's 2x, that quantity to the third power? So that becomes 8x to the third. Now I'm just going to simplify this as well. Okay? I trust you guys to simplify this. I want you guys to simplify this. Okay? Simplify that. It might be, it's just a formula. All right, here we go. So, let's see how I would do this. What would I do? Okay, I know what I would do. All right, so I would go, I'll multiply technically all this together, including the 8x to the third, because that's how weird I am. I would just do, let's see, this becomes a 3/8 with an 8x to the third up there as well, all over 6. This turns into 3/6, 1/2. Do you guys 1/2?
Yeah.
Okay, cool. All right, so then the 8's cancel out. This becomes a 3x to the third all over 6, which does simplify to be another plus 1/2 x to the third. And that is my expansion up to the x to the third. And yes, I put the dots because it does keep going after that, but still went to x to the third. This part didn't crash. Wonderful. Okay, cool. All right. So, my recording's still going. All right. So, for this one, okay, we can't expand it the way that it is right now, okay, but we're still going to the term that has x to the third. What are we going to need to do with this denominator? Huh? Make it a what? Speak up. Make it a negative. And you make it a negative by bringing this up. Y'all remember your laws of exponents? Okay? If you want to get it out of the denominator, you change the exponent. So in this case, this is a positive, bring it up, and it's a negative. And hey, look and see, is this going to be the top formula or the bottom formula? The top formula, which technically has n and then n minus, is it n minus 1 or n plus 1? It's a plus. It's a plus. Alpha's better than minus. Okay. And on top of that, this negative only applies to the 1 minus 3x. Which means that what am I going to have to do with that 2? Multiply it to each after I expand it. So don't forget about this 2. Okay. But this is still in the form of 1 minus x to the negative n power. Okay? So we're okay. We're still good. That 2 at the end, I'm just going to multiply that expansion by 2. So the first term of the expansion starts with a, we're going to multiply at the end. It's going to start with a what? It's going to start with a 1. Remember, we're going to put the 2 in at the very end. Okay? Technically, it does start with 2, but let's save that for the end. It's going to start with a 1. Use the formula. Then it goes plus n times x, right? Yes? So n is what? Are you sure? No, n is just 1. And then so it's going to be 1 times x. Oops. Is it 1 times x or 1 times something else? 1 times 3x. So it's going to be a 1 times 3x. The negatives are matching up, so I don't have to plug in any negatives here. Plus, then it goes into the fraction with the 2 factorial on the bottom. But what's on the top? N plus 1. 1 plus 1, which is 2. Then it says x to the second power, correct? So 3x, that quantity squared. All I'm doing is I'm using the formula. Then the next part has a 3 factorial on the bottom, but what's in the numerator? It's going to be n times n plus 1 times n plus 2 x to the third power. So far, so good? All right, let's simplify. Again, don't forget about the 2 that we need to multiply at the end. I have 1 plus 3x plus, what's 2 factorial? And what's 2 divided by 2? So I'm really just left with a, which becomes 9x squared plus, what's 3 factorial? 6. And isn't the numerator become 6 as well? So 6 over 6 goes away. And what's 3x, that quantity to the third power? It does keep going, but I'm only concerned for the x to the third. Now, I have to incorporate that 2 that was on the outside. I do, but it's not too bad. All I have to do is multiply this entire thing by 2. So my final answer for this expansion up until the x to the third term is 2 plus 6x plus 18x squared plus 54x to the third.
When we're getting this answer, do we always have to put the dots?
To indicate that it does keep going after that, yes. Because it is an infinite series.
Yes. It became a 9x squared.
Because we have to square that entire quantity of x. So since x is a 3x, everywhere we see an x in the formula, we plug in a 3, and we square that entire quantity. So 3x times 3x becomes a 9x squared. We okay? Alright, let's take a look at this one. This one's not as bad because we actually know what the final answer should be. We just have to do the algebra to get there. Okay? So the thing about show problems is that you basically have your answer. So as long as you do the work correctly, you should get to this point. Like that represents the answer. So if you apply the formula correctly and you do all your correct algebra, that's the point that you should get to. So in a show problem, you don't want to skip any steps, okay? You never use the answer at any point a part of your work. The only time that the answer should show up is at the end, where it should always be, okay? So, I'm not going to leave you on your own on this one. I'm going to do this one with you because we are going to need to apply some prior knowledge to set this up before we can use the formula, okay? When you take the square root of a fraction, isn't there another way that you can rewrite that? Okay, but now I have a fraction that's raised to the power, and I'm telling you, it's a lot harder to work with if you put that entire fraction to the power.
You can do it to each part, the numerator and the denominator.
When you first learned about radicals back in what, algebra 1 or algebra 2, when you were dividing a fraction, when you were taking the square root of a fraction, it was the same thing as basically taking the square root of the numerator and dividing it by the square root of the denominator. Okay? And if you don't remember that from Algebra 2 or Algebra 1, that's a refresher. Okay? Now, we can apply that whole converting the radical to a rational exponent. Isn't that right, Abigail? Yep. Okay. So then we'll have 1 plus x to the what power? 1/2. So didn't we just do this with the fraction? With the radical? And this becomes 1 minus x to the 1/2 power. Okay? So all this is doing a little bit of prior knowledge before we actually can expand this. Okay? Now, just like the last problem, we couldn't have that square root in the denominator. So what do we have to do to get it out of the denominator? Then we apply the negative and bring it up.
Yes.
We can do the same thing here. So we'll have 1 plus x to the 1/2 power, and then 1 minus x to the negative 1/2 power. And what am I going to do to these two parentheses? You are going to multiply. You don't add them, otherwise there would have been an addition symbol there, but that imaginary property between those two is going to be a multiplication. Not the imaginary property, it's the invisible property, the invisible operation. So, we're at the point now where we can expand. So, the first one, we're going to need to expand both pieces, and then at the end, we are going to need to multiply them, okay? So, am I back to orange? No, I'm not. So, this first part, the 1 plus x to the 1/2, I'm going to use the bottom formula. The bottom formula, where alpha is going to be what? 1/2, okay? And x is going to stay in x because that's how it is, okay? So I'm going to expand this first part. It starts with a 1, and then is in the alpha times x. Alpha is a 1/2, and x is going to stay in x because I don't have any additional anything with the x. And then the next one, isn't that alpha times alpha minus 1?
Yes.
So it's going to be alpha times alpha minus 1, so that's going to be a negative 1/2 all over 2 factorial x to the second power. Do I need to keep going? No, I don't. Because if I look at how the answer was supposed to be, only goes with the x to the second, so I don't need to go any further than this. Okay? Now, let's simplify this. This becomes 1 plus 1/2 x. A 1/2 times a negative 1/2 becomes a negative 1/4. All of this is over 2 factorial, which is a 2, x squared. And a negative 1/4 divided by 2, when I keep change flip, lets you turns into what? Negative 1/8. So I have 1 plus 1/2 x minus 1/8 x to the second power, and we have successfully expanded the first parenthesis. Questions? Now let's look at the next one. Gotta be careful here, because not only does it have a negative, but it also has a fraction. So the question is, do I use the numerator or do I use the top formula or do I use the bottom formula? The one on the bottom. Because going back to the formula, hopefully everybody wrote this down, you can only use this formula if n is a, what does z with the plus mean? A positive integer. And is n, that negative 1/2, that's not an integer. Even if I took off the negative, that's not an integer. So no matter what, I have to use this formula. Okay? But alpha is going to be what number? is going to be a negative 1/2. Okay? So alpha is going to be a negative 1/2 when I use that second formula. Okay? I'm going to do this one in pink. So I don't confuse the oranges. Okay? The expansion starts out with the 1, and then it's plus alpha times x. Well, alpha in this case is a negative 1/2, and I'm going to multiply that by x. Yes? Sure? Now this one we have to be careful. We already made sure that alpha is a negative 1/2 based off of the formula that I went ahead and copied into this page. But look at what the expansion is for. It's for a 1 plus x. So then that means that when I use this formula, I'm actually going to plug in what for x here? A negative x, because it's a negative here. Okay? So you got to be... That's like, I guess, another part where this can get tricky when it comes to the formula. Remembering if it's a 1 plus x to the alpha or 1 minus x to the alpha. It's a 1 plus x based on the formula. So let me actually go do it this way. I'm going to keep it as a plus. Alpha is a negative 1/2, and I need to multiply that by x, which in this case is a negative x. Now, granted, yes, a negative times a negative is positive, but we just don't want to lose any signs. Plus, now I'm going to have alpha times alpha minus 1. What's a negative 1/2 minus 1? Negative 3/2, all over 2 factorial x, which is going to be a negative to the second power. Okay? When I simplify this, this becomes a 1. A negative and a negative make a... So it's going to be plus a 1/2 x. Now a negative 1/2 times a negative 3/2 becomes a positive 3/4, all over 2 factorial, which is 2. And a negative x, that quantity squared becomes a positive x squared. And when I simplify that fraction within a fraction, 3/4 divided by 2 is going to become a what?
3/8.
And we have successfully expanded the second orange parenthesis, the 1 minus x to the negative 1/2. Now the last thing I need to do is to do what? Is to multiply that first expansion by the second one. And we're only concerned for the terms that go up to x to the second. As we know, if we multiply an x to the second times an x to the second, that's going to give me a what? X to the 4th. So I'm not going to really need to be concerned about that. I only need to multiply to get the terms that give me up to x to the second. So I'm going to actually do distributive property here. I'm going to multiply 1 by everything in the pink parenthesis, 1/2 x by everything in the pink parenthesis, and a negative 1/8 x squared to everything in the pink parenthesis. What's 1 times 1? What's 1 times 1/2 x? And then what's 1 times 3/8 x squared? 3/8 x squared. That one was the easy one. Now let's take the 1/2 x in the orange and multiply by everything in the pink. What's 1/2 x times 1? 1/2 x. Now I'm going to multiply 1/2 x times a 1/2 x, and that's going to give me a 1/4 x squared. And when I multiply 1/2 x by 3/8 x squared, do I need that term? No, because it gives me an x to the third. I'm only trying to get the first 3 terms, technically, of this expansion. So I don't need to write it. Now let's do the negative 1/8 x squared multiplied by everything in the pink parenthesis. I know the first term is going to be a negative 1/8 x squared because I'm multiplying it by 1. But do I need to multiply by any of the other 2? No, because it's going to give me an x to the third and then an x to the 4th, which I don't need. So let's combine some like terms. Can I combine 1 with anything? No. So 1 stays how it is. Are there any other x's? I have a 1/2 x and a 1/2 x. What's 1/2 x plus 1/2 x? It's a 1x. We are getting close. Now I have a 3/8 x squared plus a 1/4 x squared minus a 1/8 x squared.
So like I'll be 1 over 2
We're going to be 1 over 2x squared? Sure is. Because 3/8 minus 1/8, it becomes a 2/8 x squared, which simplifies down to be a 1/4 x squared. So 1/4 plus 1/4 is 2/4, which is a 1/2 x squared. And wasn't that what we were trying to verify? So we have done what we needed to do. Okay? Have I taught about those 3 letters?
Yes.
Okay, I just want to make sure. It's like quadrilateral. Something like that. So then there you go.